Hi there, everyone. It's John Pushkar. I'm here today in a part 3 of the series to talk about gas line inspections, making sure that you don't have major issues with your gas lines. And today, the topic is all about corrosion. It's that lethal, silent, deadly killer of gas piping systems, and sometimes a killer of people. And it's a topic that not a lot of people know about. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. So I'm lucky enough today to be joined by a good friend of mine, longtime colleague, Mark Kosak. Mark, say hello and tell us a little bit about what you've been doing during the pandemic regarding corrosion projects.
Hi, John. The corrosion doesn't sleep like the pandemic, so it kept going. And I've been working on major projects in Cincinnati on some distribution pipeline. And then I was down in Florida, actually, in the breakout of the pandemic, working for Enbridge Pipeline to supply a transmission line to Duke Power Station, where they're mothballing a Duke or a nuclear plant for Duke Energy and bringing on a gas turbine power plant. And then I came back up here to Ohio, worked in Hamilton, and now I'm currently in Wadsworth area working for Mears on projects with the Enbridge Pipeline.
Gotcha. So kind of like Neil Young said, so rust never sleeps, huh? So you and I worked together at one time. We did some gas piping inspections. In fact, we had a checklist and a program for a major power producer. We traveled to plants throughout the United States looking at their gas piping systems. And I hate to spend too much time on nostalgia, but if I'm remembering correctly, didn't you also do some gigs at some foreign countries as part of that project?
Yes, for AES power supply in South America. There was some eye-opening experiences there with multi-gas facilities where we had bleed through and corrosion problems. And I think we had to shut down the plant at one time. We had some problems there. But in all of the inspections, I noticed it was the first experience I had on the other side of the gas meter, so to speak, where it wasn't regulated by DOT or federal regulations. And it seemed corrosion issues were either neglected or not made aware of to the owners of the facilities, and they kind of neglected that. And a relatively cheap fix or relatively easy monitoring of their systems could have eliminated major downtimes and potentially dangerous situations for them.
So Mark, what you and I have talked about in the past is that gas utilities and regulated entities, they have whole departments of people for this stuff, right? They know they have to manage these assets. But what I think we've found, that I appreciate if you could address a little bit, is that when the gas gets to the other side of the meter, the utility pops up above ground, they've got a meter set and some isolation valves, maybe some pressure regulation. Then oftentimes at like large steel facilities we've done or large power plants, it ducks back underground. What kinds of things are there? What should people be doing? What are they not doing? How does one go about managing that asset in the industrial world? Like you said, on the other side of the meter.
They need to know what type of system they have on their facility. Is it plastic? Is it steel foam? Where is it located? Where are these lines going? Has it been monitored? Do they have an outside firm or somebody in charge of maintaining that? They have maintenance on their all their equipment, making sure that they're well maintained, but they neglect the underground piping because they can't see it. It's out of ground. Many times management changes or new construction, buildings added, and the piping changes and it's not updated in their system, and it's not being basically watched over to be taken care of. So it's not a constant thing, but it maybe once a year on the steel underground piping to monitor it, to get readings on it, to understand. Or they don't contract with an outside company to do that for them that understands and advises them on how to keep it safe and keep it running safely.
And so when you say monitoring, you're talking about a cathodic protection system. And when we say that, tell us about what they might see. How do you know what kind of system you have?
Well, if they don't have, if it's a smaller facility, normally it's underground steel. They may just have a galvanic system, which is mainly magnesium anodes attached to their system to create a low voltage to protect the pipe from straight from current, loss of pipe, which is caused pitting, and then that causes a leak and explosion. The larger facilities may have a rectified system where it's a DC current that's fed by AC power that's converted to DC that basically is more powerful than the galvanic. Think of it as a flashlight battery versus a light in your house that you turn on. The battery would be the magnesium anode for smaller lights, but for larger lights, you would need a big electric 110 switch. And all they have to do is rectify systems, monitor every other month to take the voltage and the current on it, to make sure the rectifier is working, and a yearly testing of that. And as far as the galvanic, it's just yearly to make sure that the anodes are putting out the limited amount of low voltage current to protect their pipe.
Gotcha. So it's not necessarily an instantaneous reading, but it's changes in those readings over time that might indicate that you're heading towards a problem?
Yes, yes. And you want to monitor it quickly in case something does change drastically, and you could troubleshoot it and find out what's causing that problem. It could be something simple as a fuse on your rectifier or a broken wire on your anode leads for your test boxes, and or a bad flange that goes into your building. You have to insulate your inside piping from your outside underground piping, because when it's inside, it comes up through the riser or a valve to the outside of a certain building. It touches the metal, it touches the grounding of all the piping inside, and it gets shorted out. So you want to keep all that separated. That's the main reason the utilities, once it comes into your meter station, when you get your gas from, they insulate that off right away. They don't want to be shorted out, so to speak, to your problems. They want to protect their stuff.
So I think what you're saying is, so the utility isolates from the customer, but then the customer should be isolating from itself. Where it
Correct.
comes above ground, you don't want all that piping electrically connected. And when you say isolated, you're talking about gaskets, washers, bolts?
Yeah,
What are you
just a
talking about?
simple phenolic gasket. Sometimes plastic pipe is used, but mostly it's a flange gasket. Sometimes it could be a Zunt weld-in fitting. A lot of times they have a plastic riser that comes up. It's a perfection riser, they call it, that's will never deteriorate underground, so it fuses the plastic and it changes. So there's many ways to isolate it, but the main thing is you don't want your underground piping to be shorted to anything that goes above ground or touching any foreign object.
Gotcha. So we've now been talking about underground corrosion, and I'm showing a picture on the screen right now that's showing people what they might see at a facility. So what we're looking at here, Mark, is the little device that people have often seen that comes up. There's a little plastic cap at the top. You take that cap off and you see these wires there. Now, no one's going to get shocked by those wires, right?
Hopefully not, unless there's AC induced on that current.
Okay.
You never know. That's what we always say, use safe devices to test it. But normally it's low voltage DC. And depending on your type of operation, it could be wires attached to the main. It could be an anode connection in that box that's separated from the pipe that makes a connection up inside the box. It could also be a buried reference cell that you can use to take a measurement off of that as well. On a rectified system, it's normally just two main wires that you just take the read from. And normally they run two wires off the main. And in case one of the wires breaks, they use the second one as a backup. And that's identified by color code. And sometimes it's labeled inside the fink head, it's what it's called, or it's on your drawings, your construction drawings, what wire denotes. But we have ways, corrosion technicians have ways to test that and identify which wire is doing what.
So these are not to be ignored. If you've
No.
always wondered what they were, they serve a purpose, and in fact, a very important purpose to help you manage that asset.
Yes, and especially if it's over a buried insulator and one pipe is insulated underground. If you connect those wires or they're shorted together or break off and you connect the wrong ones together, you could instead be creating a problem for yourself. Or you could be shorting that wire off to good piping versus bare piping or unprotected piping. So you really need to identify what you're doing and have a known technician connect those wires and repair them if it's ripped out. A lot of times lawnmowers will run them over, equipment will run them over, and then they cause problems. When they're meant to monitor it, they're actually causing a problem. So you need
Gotcha.
to be aware of what it does.
Hey, Mark, so let's say somebody ignores this and doesn't get touched forever. Who cares? What's the worst that can happen? Give me a little bit of a horror story. How bad can it get? You were telling me about a truck plant or something at one time. Go ahead with that story.
And this was in Indiana, a major truck plant, and they were under the deep throngs of production. They were shut down for a strike for a while, and they got back online. And next thing you know, while they were off, they didn't do any monitoring repair, and they noticed gas bubbling near one of the buildings. Well, they had to shut the whole facility down for a leak and caused by corrosion, by not monitoring the pipe. And they called us in after the fact to figure out what it was. And here they were losing $250,000 a day, and they were down for 2 full days. $4 million lost. And a simple gasket wasn't installed correctly on one of their valves. Their actuator valves go into the buildings. It was on the wrong side. It was getting electrically grounded and shorted out their whole piping system. So not only did they have to repair the pipe temporarily, the rest of their pipe was being degraded. And now you don't know if the whole thing has to be replaced or not. So for a simple $10 gasket, flange gasket, it cost them $4 million, an unknown cost in the future.
Yeah, that's the funny thing about corrosion, isn't it? I mean, it's not funny, it's very sad, is you never know when you're done, do you?
No.
You'd have to dig up all that pipe and just sit there and look at it, which, you know.
Right. And there's ways to test it. And the main thing I would tell facilities is know where your pipe's at and monitor it. Anybody digging around it, make sure you have one of your employees or inspector watching it so it's not nicked. Coating is your biggest, you wouldn't need my job if pipe was 100% coated, steel pipe, but it's not. All we're protecting is the nicks and the little imperfections in the pipe, which we call holidays. And once those are protected, a little bit of current can protect it. So it's a very simple process, but it can be major problems if it's neglected.
So people not only coat pipes, but they coat pipes and they cathodically protect them?
Yes.
And it's all just because of those little imperfections?
Right. If there's no pipe coating that's developed yet, it's getting better and better, it's 100% effective. So one little microscopic pinhole in the coating from the factory, or the pipe sitting on a rock underground and rubbing against it causes some coating loss, can cause what they call a holiday. And that is where the function of the pipe will start to lose pipe wall. It'll give it up to the earth. And then eventually you'll get a pit, and then that pit will get deeper and deeper, and you'll get a leak. And if that leak's big enough, it can cause an explosion, a rupture in the pipeline.
Gotcha. And so one last topic I want to cover with you, and that's exterior corrosion. And I remember a couple of things you taught me a long time ago had to do with the fact that paint on pipes is not necessarily to make them pretty. It does that, but it's part of an exterior corrosion protection system. And I think you first gave to me the concept of pipe thickness measuring devices. I had never seen them before. Can you talk to me a little bit about Like, should people be checking thicknesses on painted pipe, like on a regular basis? How thick does it need to be? And then also, please, at the end of this, mention NACE and what NACE is and how they could help.
Okay. And the thickness gauges is certain millage. It depends on the area where you're at as well. If you're near seashore or northern Ohio.
So if you're where your background is,
Yes. Yeah,
it's
if
a
you're in
problem.
a
Yeah.
marine area, you will experience a more rapid loss of your coating on your pipe. And that's UV, and it's just natural elements. You want to keep certain millage because you'll lose so much mill. I don't have it in front of me, but so many mils a year you'll lose. And so you want to keep that millage thick enough so you don't have pipe wall loss. Now everybody thinks, well, pipe uncoated, eventually you'll get rusty, but that rust is not that bad of a thing. Look at the bridge. San Francisco Bridge is got rust on it, but that rust protects it. But the protection, it provides a coating on it naturally. What you want to watch is for pipe wall loss, which is pitting, when your pipe starts pitting. So the easiest way to prevent any of that from happening is to keep it coated. And there's good, any pipe coating place will come up with, the newer ones are getting better and better at application and UV protection to prevent the pipe wall loss eventually. You're going to lose some millage naturally. It's going to happen. But,
So
and
tell it.
NACE is a National Association of Corrosion Engineers, and it's certified professional engineers that are tested, and we have testing, we have education, we have studies, working with the governments and pipeline tested, and we have testing, we have education, we have studies, working with the governments and pipeline industry to protect pipe, both above ground in bridges, to protect steel, and to any different types of corrosion as well. And I'm a NACE certified 2, which you have your NACE certified 1 is a regular technician certified to do reads and basic troubleshooting. 2 is advanced troubleshooting and design. And then you have your 3 and 4 in higher areas that actually design power plants and underground transmission stations and stuff like that.
Gotcha. So NACE is kind of like the brain trust for everything and anything corrosion related. And they have a website. In fact, you used to manage the website, didn't you?
I do subsets of the NACE, the interference. Every state's required to have interference commissions and groups that meet regularly to, once you install a rectified system or transmission, to let other people know that you're protecting this pipe or this new pipe is here, so as not to interfere with your pipeline that you've already had in ground. And I do Pennsylvania, Ohio, Illinois, Detroit, Indiana. I do a bunch of them for the groups to help them out and to store their cases where they submit cases. And it's a good meeting point as well to discuss with speakers and problems and ongoing training like any professional organization does.
Gotcha. Well, Mark, I really appreciate you taking a few moments out of your day here to update the world about corrosion protection. You're opening up a lot of eyes here because I think a lot of people look at piping and they think, oh, look, it goes underground. So what? Oh, look, it's a little bit of rust. So what? But you and I have seen firsthand that can devastate a facility. It could lead to explosions and fires. It's another one of those things that seems like pretty intuitive and straightforward, but if once you dig below the surface, no pun intended, there's a lot going on there. So folks, Mark is representative of the quality of the type of people and the depth of experience I have in my network. If you are looking to start some type of a piping inspection program, again, this was part 3 to educate you a little bit about corrosion protection and how that has to be part of any type of piping inspection and program that you might want to get started. Once again, I want to thank you for being here today, Mark, And thank you folks for listening in on another wonderful episode. Hope there was some nugget of information here that you all could use. Thanks again.
Thank you. Thank you, Jerry.
Hopefully you found something here of value that you can pass on to friends or coworkers. If you can, please hit the like button and share this video. And I'd also like to invite you to the Prescient Technical Services online school, where you'll find more than 20 modules that I've created from knowledge I've acquired over the past 40 years, traveling over 3 million miles and being in and out of more than 300 industrial plants in 12 different countries. So once again, thank you very much for being here. It's my mission to pass on important life-saving information. I'll be releasing one of these videos just about every week. And if you could subscribe and the link below, I'll make sure that you get first notice of every time a new video comes out. Once again, thank you and please have a safe day.